Hi, welcome. We're going to talk about fractions today and how they're misunderstood by most. My name is Teresa Foltin, and this is based on the work of Dr. Joan A. Cotter. So fractions generally have a bad reputation. They even make them into cartoons, right? So here, the Peanuts characters are saying, now say, we have cut an apple in half. We have two halves, don't we now? That's fractions. You're trying to teach me fractions. You know I'll never understand fractions. What are you trying to do to me? I'll go crazy. So fractions are often viewed as incomprehensible and unpredictable and even scary. But this is a huge misunderstanding. Fractions are necessary and useful. Look at this. It's 2:15. Even coins are fractions of a dollar. And we all know that we use fractions in cooking. Fractions are really amazing. So let's look a little bit at the history of fractions. The Latin word frangare means to break. Fractions were often considered only as part of a whole. They could never be equal to or more than one. And this is what that would look like. You have 1/2, 1/2, 1/3, all the way down to 1/10. That is less than 1. That's how fractions were considered. But in the 1600s, the concept of fractions expanded, and they now included the idea that it was division. There was a division perspective. Fractions could be equal to or more than 1. Now let's look at 1/3. In this case, this is looking at it as a broken piece, part of a whole. So here we have one whole. It's divided into 3 equal parts, and we're going to have one of those parts. So that's 1/3. But what about 2 halves? In that case, we have 2 pieces. We divide them in half, and we get 1. Right? Okay. How about 2/3? Now you could look at this as a fraction, a part of the whole, or you could look at it with a division perspective. So here we could say we have 2 pieces divided into 3 equal parts, and there we go. However, this is going to show you that it could also be viewed as 1 piece divided into 3 equal parts, and we get 2 of them. Okay, so that's the comparison between the old way of looking at fractions and the new. In summary, old fractions were always less than 1, and new fractions can be equal to or greater than 1. Now remember, the new is from the 1600s, so it's not like it was yesterday that they came up with this. All right, old fractions were written like this, 1/3, but the new fractions could be 1/3, 3/3, 4/3. In the old way, whole is fractured, but in the new way, a fraction is division problem. In the old way, familiar meant proper, or proper meant familiar, and improper was unfamiliar. But in the new way, improper was an okay way of doing fractions. So 4/3 would be an improper fraction. That was acceptable. The old fraction was a limited view. The new one supports understanding. Now let's think about, how has most fractions been taught? Maybe even when you were a kid, how were you taught fractions? Most of the time it was done with circles or pie charts. Problem is, it's really hard to tell. Are you comparing angles or arcs or area? And then how do you compare whether 4/5 and 5/6, is 4/5 bigger than 5/6? It's hard to see that. Experts in visual literacy say that comparing quantities in pie charts is difficult because most people think linearly. It's easier to compare along a straight line than compare pie slices. Okay, but specialists also suggest refraining from using more than one pie chart for comparison, which begs the question, then what good are they? if you can't compare two pie charts, why are we using them? So you might wonder, how then should we teach fractions? And I would like to propose we use a linear chart. Okay, let's see how that would work. Here is 1/5, here's 3/5, here's 5/5. And once we get past this, we can just keep going. Here's 6/5, for example. So the child can see right away, oh, okay, I've passed 1, I've gone outside of the frame of this fraction chart, and now I keep going, right? So that's what 6/5 is. This chart, there should be one complete one and one that's cut up into puzzle pieces. You just cut along the lines. And the child should be told to put it together as a puzzle. So this is what that would look like. Just building the fraction chart with the puzzle pieces. Now, this is a great way to introduce fractions at a very early age so that the child becomes very familiar with how fractions relate to each other. They can also build things like fraction stairs. And you can ask your child, could you walk up those stairs? And the answer is no, because while there's a nice step between, say, 1 and 1/2 and 1/2 and 1/3, as you go up higher, there wouldn't be any room for your foot, right? So the difference between the pieces gets smaller as you climb those stairs. Another cool thing is that makes a hyperbola. So you could introduce that, the concept of a hyperbola. The child could build stairs from the center, and you could have 2 hyperbolas, right? So you see, if the child is using these fraction pieces to do creative things like this, building stairs and whatnot, they are learning intuitively the difference between fractions, so that when they start adding them and multiplying them and dividing them, they're not scary. They're no longer terrifying. If you wait until a child is in 3rd, 4th, 5th grade and you introduce fractions, then all of a sudden, you know, it is more intimidating. It is a struggle to understand them. So you want to start young and let them play with these. And if you don't happen to have started young, you can have the older kids step back a pace, go ahead and build these things, do these activities so that they become familiar with them and that they are seen as fun and interesting. All right, so some people have said, great, a linear fraction chart, that's awesome. That seems to be the way to go, but gosh, isn't it a little boring? You know, it's just white and green. Let's spice it up a bit and give it some color. Do you see what that did? Oh, all of a sudden it took away everything that you could see before, all the patterns that you could see, and now all you're focused on is color. And the color is not what determines, that has nothing to do with fractions. So it's really a distraction. All right, now some people said, okay, fine, no color, but you know what, we don't use 7ths and 9ths, so let's go ahead and take those out, but we do use 12ths, so we're gonna add those in. The problem with that is it messes with the pattern that the kids can see in the fraction chart. So let's look at what that pattern looks like. So here we start down here at the 1/10, and we go all the way up to 1 and back down to the 1/10 on the right side. There's this nice big arch. And another one, if you start in the second one in, you go up to the 1/3 and back down to 1/10. You can keep doing this all the way, and you see all of these really neat arches. That is a great pattern for the kids to focus on. The other thing that you can see is that you have a number, a line, a number, a line, a number, a line, all the way down. That's another good pattern. Remember, our brain likes patterns, so it's really helpful if the kids can see these patterns. Now, if I go back and I show you where the missing pieces are, all of a sudden there isn't that nice pattern down the center. After 1/5, there are no more odd fractions, so it's just one straight line. That does not help the child understand what fractions are. Okay, so how should we practice what we've learned? Well, I'd like to propose games. Games are to math as books are to reading. And just like you would give your child an interesting book to practice their reading, you want to give them interesting games. Games provide instant feedback. Games provide interesting repetition needed for those automatic responses. And that's the goal, right? That's why people tell their kids to memorize multiplication charts, for example. They want the automatic response. The problem is that if it's not in context, like in a game, then memorizing a multiplication chart or memorizing your fractions facts is like you memorizing your friend's recipe for meatloaf. That doesn't make any sense. Instead of memorizing the recipe, you're going to use it frequently, and eventually you'll have it memorized. Well, that's the same thing with games. We want the kids to be playing games to help them use their math facts, and therefore, in the long run, they actually memorize it. Okay, so the other benefit is that games provide practice in a social setting, which children enjoy. But most importantly, games provide an application for the new information. That means they want to learn what they've learned because they want to beat whoever they're playing the game with, right? All right, so what is one game that we could use for fractions? How about unit fraction war? Remember, a unit fraction is any fraction with the 1 in the numerator. So 1/2, 1/3, 1/4, not 2/3, for example, okay? The purpose is to practice naming and comparing unit fractions and to help the child realize that a unit fraction decreases as the denominator increases. The goal is to collect all or most of the cards by comparing unit fractions. All right, so we have a fraction chart and we have 2 piles, 1 for each of us. We flip over our cards. I got 1/4, you got 1/5. We're not sure who won, so we compare it on the fraction chart, 1/4 to 1/5. I get those cards. All right, flip over cards again. I got 1/8, you got 1/2. Clearly you won that hand. Now we both happen to turn over 1/6. That means war. So we place a card on top, face down, and flip over another card. The winner of this takes it all. So I got 1/3, you got 1/4. So I get all 6 of those cards. And the game continues with, until you're out of cards, or until, if you want for a longer game, you play until somebody gets all of the cards. All right. So the next activity you could do with fraction chart is to ask, how much do you need to make a whole? So for example, how many fourths are in a whole? Well, I don't know, so let's find out. There's 1, 2, 3, 4. 4/4 makes a whole. How about fifths? How about eighths? Right? The kids will catch on to the pattern. 5/5, 8/8, and you keep going. Another game is concentrating on 1. The purpose of this game is to help the child realize that 5/5, 8/8, and so forth make a whole. So, just like any concentration game, you're going to find pairs. Here we have the cards turned over. They are a select group of cards to make sure that we have the right pairs. I'm going to flip over a card. I have 3/5. What do I need to turn over to complete the pair? Well, let's look at the fraction chart. Okay, so I have 3/5. I'm going to need 2/5. Oh, yes. Okay, so I got 2/5. So I win that hand and I get to go again. Turn over 3/8. What do I need? So I have 3/8. Oh yeah, okay, I'm gonna need 5/8. And no, I got 7/8. So my turn is over and now it's your turn. Oh, look at that, you turned over 5/8. There we have it on the fraction chart, 5/8. What do you need? 3/8. Do you remember where it is? This is why you're concentrating. All right, you got it. So 3/8 and 5/8 makes a whole. Obviously, you keep going until all the pairs have been made, and then you can just compare the height of your stacks to see who won. All right, let's begin to compare fractions. Which is more, 3/4 or 4/5? Well, let's see. Here's 3/4. There's 4/5. Which is more? Oh, 4/5 is. Okay. How about 7/8 or 8/9? 7/8, 8/9. Ooh, that's really close, but 8/9 beats it out, right? All right. So let's go back and take a look at those pie charts again. Which is more, 4/5 or 5/6. Now, you might know which is more because of the linear chart, but if you're just looking at this, it's very hard to figure it out. So which model is easier? This one or this one? I would propose, and I think you would agree, that the linear fraction chart is much easier to see, to visualize, and to use. Okay, let's keep going. We can take those puzzle pieces and make a partial chart. Okay, so here we have the 1, the halves, the fourths, and the eighths. And I'm going to do something that you can't do in real life, but it's really a kind of a cool demonstration. I'm going to erase those horizontal lines, and I'm going to erase the numbers. What do I have left? What do you think that looks like? A ruler, right? Yes. Okay. So maybe you never made the connection that there is this relationship between a ruler and a fraction chart. The next game we're going to play is Fraction War, and the purpose is to practice comparing ones, halves, fourths, and eighths in preparation for reading a ruler. The goal is to capture all the cards. All right, we still supply a fraction chart to refer to, and here we go again. We flip over the cards, 3/8 or 1/4. Let's compare. Ooh, there we go, 3/8. I got that one. How about 5/8 or 3/4? Okay, you got that one, 3/4 one. And now there's war again, 3/4 and 3/4. So we put one card face down, one flipped up, and we know that 3/8 is larger than 1/4. Okay. We can also do equivalent fractions. For example, how many fourths equal a half? Well, here's your half, and you could just pick up this puzzle piece and slide it down so that the child can compare, when the fourths make a half, right? But on the PowerPoint, you can just see it this way. We'll highlight it. Okay, so how many fourths equal a half? 2. How many eighths equal a half? 4. How many sevenths equal a half? What? Sevenths? Sure enough, you can answer that. It's 3.5 sevenths. Okay, what do you do about fractions greater than 1? Well, here we go. Just add a puzzle piece to the side of the full chart, and all of a sudden you can go greater than 1. Okay, so here we have 9/8. We could also do, for example, 5/3. And then let's just do a normal one, a proper fraction, 3/4. And you can ask your child, okay, so which fractions are proper fractions? And of course, 3/4 is a proper fraction. So anything less than 1. And then you can ask, okay, which ones are improper fractions? So of course the 9/8 and the 5/3 are not less than 1. So they're improper fractions. Now we can rewrite those improper fractions using a whole number. So let's look at the 9/8. What whole number do we need to use? 1 and 1/8, right? Okay, 5/3. We use 1 and 2/3. So there, that was pretty painless. I found it difficult when I was in school to understand why we were rewriting these numbers and how to get them, and it seemed complicated. And we were probably told how to do it instead of letting us figure out how it works. But in this way, using these linear charts, it's so intuitive. The children can see it right away, that it's 1 and 1/8 or 1 and 2/3, etc. All right, let's try adding fractions. So we have 4/5, and we're going to add 3/5. So how many do we have? We have 7/5. Now, at this point, don't tell them, oh, you know how you can do that. You don't need the fraction chart. You can just add across. Don't tell them that. They'll figure that out. And when they figure it out, when that light bulb goes off for them, they'll remember it, right? Okay, so here we have 7/5. We can rewrite that as an improper fraction using a whole number, 1 and 2/5. So you didn't even have to tell them on that one. You know, you don't point out that 7 divided by 5 goes into 7 one time with 2 left over. You don't have to do that. This is a much easier way for them to understand what's going on, because if you try to tell them the algorithm to figure it out before they understand it, then it's going to be much harder to understand what's going on later on. Okay, let's try it again. 5/8 plus 7/8. 5/8, 7/8, and we have 12/8. Rewritten, it's 1 4/8. Help your child discover the algorithm. So you could say, so, you know, once you've done this several times, so do you see a pattern? Have you figured out how this would work if you didn't have a fraction chart in front of you? Those kinds of things. You just ask them these open-ended questions to spur on, you know, their thinking about, oh yeah, you know, I see now the relationship, okay? Help them to discover the algorithm. So what you have been obliged to discover by yourself leaves a path in your mind, which you can use again when the need arises. So that's like the light bulb going off that I was talking about, right? You want those light bulb experiences for your kids so that they remember. Now we could look at simplifying fractions, okay? So here we have 5/10. What does 5/10 simplify to? 1/2. How about 4/8? Also 1/2. How about 3/6? 1/2. How about 2/4? Also 1/2. All of those simplify down to 1/2. Now there's another way to look at it. We just take a multiplication chart, and for example, we find 5/10. If we move all the way to the left, what do we have? 1/2. Isn't that cool? How about 4/8? 1/2. 3/6, 1/2. 2/4, 1/2. So did you know that you could use a multiplication chart to simplify fractions? It's very cool. How about 21/28? Will it work for that? Let's see. Scooch all the way to the left. It simplifies to 3/4. Now, the numbers don't have to be touching. They just have to be in the same column. So let's look at this one. 45/72 simplifies to 5/8. Okay. Why does that work? Well, if you notice, the 45 and 72 are in the 9s column. So basically, all you're doing is saying 45 divided by 9 is 5, and 72 divided by 8, divided by 9 is 8, right? Okay, that's why it works. Let's find 12/16. Okay, there it is here. Now we're going to move to the left, 6/8. But that is not simplified as far as you can go. So if we find 6/8 up here, up above, we move to the left. Okay, so 12/16 is simplified as 3/4. Now, I chose that where that 12/16 was for demonstration purposes. You could also have found it here, and obviously that would have been easier to see. 12/16 scooches over to 3/4, right? Simplifies to 3/4. Remember, let your child discover the algorithm, okay? Hold back on telling them how to do it and let them figure it out. Let's look at adding fractions. What is 1/4 plus 1/8? Well, you can just pick up the 1/4 piece, slide it down. You see that it's equivalent to 2/8. Scoot the 1/8 over. That's what we're going to add to it. Slide the 1/4 down, and you've got 3/8, right? So 1/4 plus 1/8 is 3/8. And you didn't even have to talk about finding a common denominator. Now, we all know you need to find a common denominator eventually, but it's good for the kids to see that they can do it intuitively. All right. How about 1/2 plus 1/3? Now, we do need to find a common denominator, and we can look down and see, okay, 1/4 isn't going to, the fourths aren't going to work because it's not dividing the half into 3 pieces. But the sixths will work, right? So 1/3 is equal to 2/6. We bring that down. And 1/2 is equal to 3/6. So we put that in. So our answer is 5/6. This is a very easy way to introduce adding fractions to your children, and they're not going to cry about it, right? It's a fun way to do it. It's interesting, and it'll stick. So that was addition. That was pretty easy. But what about multiplication? How does that work? All right, what is 1/2 of 1/2? Now we can see this pretty easily, that it's going to be 1/4, right? Just by comparing the pieces. How about 1/3 of 1/2? It's 1/6. That is multiplying fractions. That was pretty easy. All right. Now, multiplying is not exclusively repeated addition. And oftentimes we think of multiplication as just repeated addition. So let's look at that. 4 times 4 is 4 plus 4 plus 4 plus 4, repeated addition. But 1/2 times 1/2 is not 1/2 plus something, right? So area is a better model for both whole numbers and fractions, actually. So here, this is 4 times 4. We can see that it's 16. But we can also do that with fractions. So we have 1/2 of 1/2. We already know what that is because we just did it on the fraction chart. But we can also do it another way. Draw a square and divide it in half and crosshatch one of those halves, because that's what we have is 1/2, right? Now you divide it in half the other way and color 1/2. And what you're left with that is both colored and crosshatched is your answer. That would be 1/4. Okay? Let's try it again. 3/4 of 2/3. So we're going to draw the square, divide it into fourths and crosshatch 3 of them. Then divide the square into thirds, the other direction, and color 2 of them because we have 2/3. Now our answer is 6/12. How did we get that? The total number of rectangles is 3 times 4. And the number of colored crosshatched rectangles is 2 times 3. But we don't want to tell the kids that right away. We want to, I would say, at least 10 of these squares using different fractions to multiply, and then ask them, so do you see a pattern? And if they've done it enough, they will see the pattern that, oh, you just multiply 2 times 3 equals 6, 3 times 4 equals 12. But let them discover that. Don't spoil it. Okay, what about dividing fractions? Well, what is division anyway? 6 divided by 2, for example. That means how many 2's are in 6? So we have 6 circles here, and we group them into 2's. We see that we have 3 groups. All right, how does that work with fractions? So let's take a look. 1 divided by 1/2. We're really asking how many halves are in 1. So let's scoot that up. There's 1 and 2. So there's 2 halves in 1. Okay. How about 1 divided by 1/3? That's how many 1/3s are in 1. There's 1, 2, 3. Okay, so our answer is 3. How many 1/4s are in 1? 4. How many 1/5s are in 1? Hopefully by now you've seen the pattern. The answer is 5. How many 1/6s are in 1? 6. How many 2/3s are in 1? So let's look. We'll take 2/3, bring it up to the top. So we have 1 of them for sure. And so we have 1 and 1/2, right? So how many 2/3s are in 1? 1 and 1/2, also known as 3 halves. Okay. How many 3/4s are in 1? Here's 3/4, bring it up to the top. We have 1 3/4 in it plus 1/3. So we have 1 and 1/3 3/4 in 1, which is also known as 4/3. How about How many 2/5 are in 1? 5 halves. You see the pattern? How many 5/8 are in 1? 8/5. How many 4/7 are in 1? 7/4. Remember to guide the child to make the discovery. So after you've done several of these problems, you can ask the child, so what pattern do you see? They'll see it pretty quick. All right. That the answer is the inverted form of the divisor. And how will the child practice this? Of course, games. Now, we do note that we have more than just fraction war to play. There's many more games for fractions besides war, but it's very easy to demonstrate on the PowerPoint, so that's why we're using it. Okay, so the purpose of fraction division war is to practice dividing fractions and to help the child realize that the quotient, the answer, is the inverted form of the divisor. The goal is to collect all or most of the cards by having the greater quotient. We'll start off with ones being put out there. That's just stable, they don't move. And then I will turn over a card and you'll turn over a card. I turned over 1/2. So my quotient is 2, and yours is 4. So you got those cards. Now I have 3/8 and you have 2/3. So 3/8, the answer would be 8/3. 2/3, the answer would be 3/2, and I get those cards. All right. This keeps going until the stack is gone or until one person has all of the cards. So now let's look at this. We already know what 1 divided by 1/4 is. How many 1/4 are in 1? There are 4. So without actually doing the math, let's look at the next problem intuitively. What is 2 divided by 1/4? Hopefully you said 8, right? It would be twice as much as the problem before it. And this is why that works. 2 times 1 divided by 1/4. 2 times 4 is 8. Okay, let's look at the next problem. We have 3 divided by 1/4. So how many 1/4 are in 3? Well, it should be 3 times your first answer, right? So here we got 12. This is how it works. 3 times 1 divided by 1/4, which of course equals 12. Okay, now still you could do this intuitively, right? So you have how many 1/4 are in a half, or 1/2 divided by 1/4. Well, if you know the answer up here, right, you could figure out what this answer is down here, which we will do. It's 2. And this is how that math works. 1/2 times 1 divided by 1/4, which is 1/2 times 4, and it equals 2. All right, how about 1/3 divided by 1/4? Do the same problem. 1/3 times 1 divided by 1/4, which is 1/3 times 4, which is 4/3. How about 3/4 divided by 1/4? 3/4 times 1 divided by 1/4 gives us 3/4 times 4, which gives us 12/4 or 3. Okay, so most people think dividing fractions is really complicated. But once you look at it this way and show the relationship and how you can figure it out, it's much easier. Okay, so let's take a look at this linear fraction chart again. What makes it so efficient? Well, it allows the child to explore the whole picture and the relationship within the whole. And it uses this linear perspective. Remember, it's much easier for our brains to see things in a line than in a circle. And this is what makes fractions understandable, fun, and not intimidating. Okay? So in conclusion, math needs to be taught so that 95% is understood and only 5% memorized. And Dr. Cotter says, our goal as teachers of mathematics is to help our children transform, expand, and refine these beginning ideas into deeper mathematical thinking. So I hope you've learned a lot from this presentation, Fractions Misunderstood by Most, and have a wonderful day. Thanks.